Right. Hey guys, welcome to watch our presentation video. We are Group 77. Our team is comprised by Ziwan, Zhipeng, and Zisen. So today our topic is blockchain and consensus protocol security. So for today's content, we will have 3 sections. So first we will have consensus and security of blockchain, and then we will have security of blockchain Merkle trees, and finally we will have future chain and potential attacks. So now I'm going to introduce the first part. So what is the consensus protocol? So a blockchain, because of its unique decentralized flavor, anyone can submit information to be stored onto the blockchain. So, and therefore it is important to, there are processes in place that can ensure everyone agree on what information to be added and what to be discarded. So one of blockchain's biggest promise is that it's a trustless system. So that use the community to help verify if the transactions or the informations are genuine. And for different cryptocurrency, they have their own chain and or their own networks. So different networks use different methods to verify. And those methods are called consensus protocols. So it is essentially the rule by which a network operates. They verify the transactions and help to keep the network safe. So the first protocol is the proof of work. So this consensus mechanism is most classic. And we contrast a mathematical problem that can only be solved by enumeration and publish it to all nodes. So the first node to find the correct answer wins the bookkeeping right. So to achieve the randomness and fairness, the simplest way is to use hash function, such as SHA-256 used by Bitcoin. So as I mentioned, you need to find a node that can make the first 4 or any of digits of your hash value to be 0. So for the security issues, for most security attack is based on computational power. So the first one is called forking attack, also known as 51% attack. A malicious miner sent transaction to Bob and received some goods or service in exchange for it. The miner then fork the blockchain into to create a new longer branch containing the conflicting transactions. So the payment to Bob will be invalid in this new consensus chain. So for the attack to succeed, the forked chain must be overtake the current longest chain, which means the attacker has the majority of the hash power. So the another attack is the called selfish mining. If the attacker is ahead of public blockchain by 2 secret blocks, so all mining efforts of the rest of the network will be wasted. As soon as other miner find a valid block, so attacker can just announce the 2 blocks that he was withholding. That would instantly be the new longest value chain, and the rest of network's efforts would immediately be offended or cut it off from the longest chain. Right. So then the next consensus protocol is called proof of work, proof of stake. So proof of stake reduces the amount of computational power. So it need to verify the blocks and transactions with less computational works. To be a block writer, so miner just need to pledge their stake. So more stake you pledge, the more chance you can be the next block writer or validator. So for the security issues, the first one is called adaptive attacks. It targets future committees members and try to subvert committees members when announced. The attacker can destroy the honest node through a public state because most of protocols include the global productability for future blocks processes. That is, everyone knows who the future block leader is. So the another attack is called gradient attack, which is the attacker try to influence the future committees. That is, there are several corrupt nodes in the network, and they can try to pick blocks to bias next committee. But since the number of committee grows, gradient attack can usually be addressed. So now I'm going to pass to our another team member for the next sections.
In this section, I will explain what Merkle tree is and its advantages. Then I will talk about its security. So what is Merkle tree? Obviously, Merkle tree is a binary tree data structure and it stores only hash value in its nodes. We know that a blockchain is a linked list, and in each block, a Merkle tree root hash value is stored. For instance, if we have block 1, block 2, block 3, and block 4, first of all, we get the hash value of each block and form hash 1, hash 2, hash 3, and hash 4. Then we combine hash 1 and hash 2 to get hash 1, 2, and do the same for hash 3 and hash 4. Finally, hash 1, 2, and hash 3, 4 are hashed, and we get our final hash value, which is also called Merkle tree root hash. There are many benefits of using a Merkle tree. One of the most significant advantages is efficiency. We know that blockchains are distributed, and if we want to verify one of them, we have to request blockchains from other peers. Huge amount of data needed to be transferred through network, which could be very time-consuming. But with Merkle tree, we only need to add one root hash value to each block and reduce time and storage needed. Another advantage is its security. Merkle tree is very secure and provides tamper detection. The security mainly comes from its hash function. Usually, Merkle tree uses SHA-256 as its hash function. It is a one-way hash function and provides pre-image resistance, second pre-image resistance, and collision resistance. If any data value is modified, hash value will be changed. Taking this graph example, if HB is modified, then HAB will be changed, and all the way up, HABCD will be changed. That's the end of this section. I will pass it to next section.
Thank you. So in this part, I will introduce the threats of quantum computing and some post-quantum schemes. The Schur's algorithm is a quantum computing algorithm for finding the prime factors of an integer. In a traditional computing scheme, this problem cannot be solved in polynomial time and the complexity is exponential. In Schur's algorithm, quantum computing can solve it in polynomial time and the complexity is an algorithm. This algorithm can efficiently increase the speed of breaking the current crypto system based on RSA and ECDSA and so on. Grover algorithm is another quantum search algorithm for finding the input to a black box function that produces a particular output value. The complexity is quadratic. In summary search, Grover's algorithm can accelerate brute force attacks and rebuild the blockchain blocks by finding the hash collisions. So for post-quantum schemes, it's usual to take the two aspects into consideration, the quantum security of the algorithm and its efficiency. Even though we can increase the base of cryptography to improve the security, but it also brings more pressure to decode it for the receiver. In general, there are 4 types of crypto system, and we will introduce 2 types of them. The first one is a code-based crypto system. This kind of crypto system is normally based on error correction codes. For example, Mechanics crypto system is a symmetry encryption algorithm based on the syndrome decoding problem, which is known as an NP-hard question. It's immune to Schur's algorithm and provides quick encryption and decryption methods. However, the size of the public key and the private key is larger than what we currently have in RSA and ECDSA, which may need to improve to use on blockchain. A lattice-based crypto system is another kind of scheme based on lattice problem. Some lattice problems, such as shortest vector problem and closest vector problem, are proved to be NP-hard and NP-complete problems. These kinds of schemes are strong because they can easily verify the correctness so that they can boost the building of blockchain. Lattice-based schemes need to use keys with large key size and large cipher test our size, but some variants propose a better performance of message size and the quantum security level. So in some research, the latency-based crypto system has better overall performance. The Denizium schemes has a faster performance speed, but it also has a large key size at the same time. So in the future, we need to consider more possible threats of quantum computing and find more ways to improve the efficiency of space of schemes for blockchain. So that's our presentation. Thank you for listening.